Hello, and thank you for your interest in our work on using knowledge distillation to render prompt learning techniques totally unsupervised and at the same time improve zero-shot performance of learned prompts. As we all know, vision and language models are getting better and better and at the same time bigger and bigger. Very large vision language models are difficult or impossible to use in many applications, and smaller vision language models, even after fine-tuning, don't perform as well as the big ones. Fine-tuning massive vision language models presents other problems, and so interest in parameter-efficient adaptation techniques has been gaining more and more interest in recent years. Prompt learning is one parameter-efficient solution to few-shot adaptation of vision language models. These methods work by training a few learnable prompts in token embedding space, which replace the classic "a photo of class" as input to a pre-trained clip model. State-of-the-art techniques, however, require labels for supervised training of these learnable prompts. In our approach, which we call Knowledge Distillation for Prompt Learning, or KDPL, we leverage a big teacher model instead of ground truth labels when performing few-shot adaptation. The student can be equipped with any prompt learning technique, and the prompts are trained using knowledge distillation in order to match the logits output by the teacher. The teacher network is frozen and is only needed at training time. And our distillation at the logit level also renders KDPL completely architecture independent. Okay, now for some us versus them. Here we compare 5 state-of-the-art prompt learning techniques trained using supervised learning with the same techniques using KDPL and trained without any knowledge of ground truth class labels. Note how our KDPL results are comparable to and on average superior to their fully supervised counterparts in zero-shot generalization. In these experiments, we can appreciate even more the superior performance of KDPL on cross-dataset generalization tasks. We see that across the board on all of these datasets, the prompt learning technique trained using knowledge distillation prompt learning outperforms the fully supervised base technique. With KDPL, we can even perform few-shot prompt-based adaptation without requiring any knowledge of training class names. We call this new scenario class-agnostic few-shot adaptation. To do this, we use a large vocabulary of concepts and leverage good zero-shot performance of the teacher in order to select online, during training, the best K-logits to use for knowledge distillation. Again, in this cross-dataset generalization task, we see that class-agnostic KDPL, even without any knowledge of the training class names, significantly improves the zero-shot generalization to all target datasets when compared to the base supervised approach. Thanks again for your interest in our work. Please check out our archive preprint and come by our poster at ECCV. In the GitHub repository, you'll find all code needed to reproduce our results. Thanks again, and see you in Milan.